Welcome to Brain Vision.
In this problem, we have a ball with a given mass that is traveling horizontally to the right when it strikes a 10-pound block, which is at rest, as shown. Now the block moves off after the collision, and we wish to calculate the time it takes for the block B to stop sliding. So the first thing we will do is look at our free body diagram of the block after the collision. The block has a weight of 10 pounds and a normal force, which is equal to the weight since there is no vertical motion, which is also 10 pounds. Its velocity is to the right, and the frictional force of the plane acting on the block is 0.4, which is the coefficient of kinetic friction times the normal force n. And this gives us a frictional force of 4 pounds. So we'll first apply the conservation of linear momentum, and we'll take the right direction as positive. So this tells us that the sum of the momenta before the collision must be equal to the sum of the momenta after the collision. So before the collision, we have the 1 pound ball that's in motion. So its mass is 1 over 32.2. So its weight is 1 pound divided by g, which is 32.2 feet per square second. Its initial velocity is 20 feet per second. And again, we take the right direction as positive. The block is at rest, so its momentum is 0. After the collision, the momentum of the ball is its mass, 1 over 32.2, times its final velocity, we'll call VA2. This is unknown. And the block has momentum, which is its mass, 10 over 32.2, times its velocity, VB2. So if we rearrange this equation and we simplify, we get that the final velocity of the ball plus ten times the final velocity of the block, VB2, is equal to 20. So that was after applying the conservation of momentum. We have essentially an equation here with two unknowns, the final velocity of the ball and the final velocity of the block. So if we can set up another set of equations, we may be able to solve them simultaneously. So we'll use the coefficient of restitution, which is given in the problem, and define it as the final velocity of the block, VB2, minus the final velocity of the ball, VA2, all over the initial velocity of the ball, VA1, minus the initial velocity of the block, VB1. So we can substitute our values in here. The coefficient of restitution is 0.6, and this is equal to the final velocity of the block minus the final velocity of the ball, all over 20 minus 0. So again, if you rearrange this equation, we get that VB2 minus VA2 is equal to 12. So we have two equations with two unknowns, which are the final velocities of the block and the ball. So if we solve these two equations, we get the final velocity of the block, VB2, after the collision is 2.909 feet per second. And this is positive, so that's to the right. The final velocity of the ball, VA2, is minus 9091 feet per second. And since that's negative, that velocity is to the left. So finally, If we're just concerned with block B, we want to know the time it will take before it stops sliding after the collision. So again, we can apply the principle of momentum and impulse now. So the mass of the block times its initial velocity plus the sum of the impulses, the integral of f dt, that act on the block must equal to its final momentum mv2. So its initial momentum is 10 over 32.2 times the velocity we calculated, 2.909. This is the velocity straight after the collision. The forces acting on the block in the horizontal direction are the frictional force, which we showed is 4 pounds in a time t, which you wish to calculate. And this is equal to the final momentum, which is 0, since the block comes to rest. So we can rearrange this, and we can find t, the time it takes for the block to come to rest, is 0.226 seconds.